There we go.
Hopefully this time, right?
Yeah, yep, we can see it. Great.
Awesome. Thank you so much. And sorry for the interruption. I just am new to Zoom. I'm used to a different conferencing system. So hello, everyone, again. Today's session, like we discussed, is focused on improving resilience and security in the cloud. And like I mentioned, I will be presenting the first half. The second half will be presented by Luke, talking specifically about the product offering. So in terms of what we are going to look at today, right? So I will be providing you with introduction to AWS Cloud in general, making you familiar with some of the common terminology so that you can connect with when we, in the later parts, when we're talking about the solution or we're talking about how we are making use of the services, you can connect with the terminology. I will also explain the global reach of the AWS infrastructure. So this is more relevant to customers who might need a wider footprint than just, let's say, the Canadian geography, or they need their applications deployed or their data backed up to multiple geographies. So it helps to know what kind of AWS presence is available to that effect. And this also helps in knowing the level of, one of the topics, kind of resilience, touches on high availability architectures. So knowing the fact that how things are distributed, how things are laid out, also helps understand how that affects your application design and architecture. In the last part of my presentation, I will also be going over the security in AWS, which means we'll touch upon, what does it take typically to secure an end-tier application? So talking about some of the components, whether that is network security or that is data security or data privacy, some of those items. And then we'll talk about the storage services offered within AWS. This part goes back to the resilience part where, the services available directly affect the availability of your application. What that means is these services have been designed to be highly available and very durable. And that in turn, making use of these services can improve on the data retention posture for your application. So in here, I introduce various AWS services and talk about the characteristics that they have so that you can identify the right services that are being used in the architecture. And then towards the end, Luke joins me in talking about specifically about the Discovery Garden offerings. And he talks about how these services make up the application architecture that benefits all of the customers. Again, in terms of what is AWS, AWS is, so we started doing some of the high compute work with our Amazon.com offering. And what we noticed was some of the learnings we had from running, these systems that at massive scale were directly helpful to some of, our customers in terms of their infrastructure management as well. So AWS services, as a result, was a direct result of our learnings, and we launched it as a product more than a decade ago. And ever since, we have been helping customers in various geographies to achieve their IT goals and achieve the kind of the cost efficiencies and the elasticity or the security requirement. So some of the benefits, which we'll also talk about in the next slide, for just using any cloud, I would say, we'll talk about AWS specifically, but from any cloud pretty much are, typically savings in terms of cost, because you can generally make use of elasticity components. You can pay for things that you use, and then you can shut down things when you're not using them. And you can get away without making any long-term commitments in terms of your budgets. So from that perspective, there are kind of savings and the benefits that apply to clouds in general, but there are some things that are more specific to AWS, and we'll touch upon, how AWS makes those benefits plus more available to the customers. So from that aspect, one of the things that AWS is very mature in is the security posture, right? Nothing starts without a consideration for security when it comes to any of the AWS services design. And the fact that we've been doing it for almost over a decade now with multitude of customers has given us unique insights into the security challenges, into their requirements, into some of the specific considerations that they might have. And any learnings we typically have from any of our customers, they are baked into AWS services, and they are then available to everybody making use of those services. So the benefit of using AWS Cloud is all of the learnings we have from our customers, they get packed into the services, and then they were made available for every customer's use. So you do not have to experience kind of an incident or an event yourself to be to benefit from kind of the learnings from it, right? So chances are, if this has already been experienced elsewhere, or if the requirements have already been hardened as a result of another customer needing these, then those are already baked into the service. And we'll touch upon, when we go to the security section, I'll talk about some of the specific features that make up AWS security posture, and that help our customers then leverage that. In terms of services breadth and depth, one of the key things to sort of consider is, I think all of these points you'll see, they kind of point back to the experience of delivering value to our customers, right? So they are kind of tied to that, but they do have different sort of manifestations. And one of them is the fact that today, and we are right in the middle of a reinvent right now, so we are launching more and more services. And one of the things that I continuously struggle with is to keep this slide updated, because the number of availability zones, or the number of regions, or number of services that we have continuously keeps changing. And that kind of goes back to reflect the pace of innovation that we are able to offer our customers. Again, directly, it's a direct result of our interaction with our customers and our kind of like what we are hearing that they need. So as of today, we have 175 plus services that we offer in the cloud, and they make up services from anywhere from just regular services about storage or running a virtual machine in the cloud, to VDI solutions where you can do workspaces and kind of like virtual desktops in the cloud, or to fully managed data warehouses, or analytical systems making use of big data, machine learning, you name it, right? So these services make up the fact that a lot of these services are available makes actually it makes a difference to our customers, because even if they're getting started, let's say today, with a typical website, right, or a typical 3-tier application, chances are, as their data grows and their needs grow beyond just the website, right, maybe they're adding some kind of sentiment analysis to this website, maybe they're capturing the user experience through the click stream, and they're making analytics on top of it. So whatever their future kind of use cases be, or today's use cases be, chances are there are already services and solutions that are kind of geared towards achieving that for our customers. So the fact that a lot of analytical solutions are available, the fact that even within each of those solutions, there are multiple sort of features, multiple variations as to how customers can leverage that. I'll pick on, let's say, one of the very common services called RDS, Relational Database Service. I picked that service because majority of the times that service is useful. It's kind of the very essential or basic building blocks. So when we talk about RDS itself, we offer a variety of database engines there. We offer MySQL, we offer Postgres, we offer SQL Server, we offer Oracle. So from that perspective, you will notice that one of the key things we strive for is to, it does not matter where the product comes from. If our customers need it, we don't care if it comes from competition. We will generally make sure that it is available to our customers. So whether that's Oracle, whether that is SQL Server, or whether that is products like open source products like MySQL or Postgres, if our customers need it, we go out of the way to make sure that those are supported. And that results directly into the number of features and the number of services that we launch. We talked about the experience. We have more than 1 million customers today. but that also reflects in terms of our global footprint. And we'll expand on some of this in the next slide. So I'll not go deeper on this point, but the idea here is the number of geographies that are available for our customers to be able to deploy their solutions, the way each of these geographies are laid out. And like I said, we'll go into details when we get to that section. I think is a direct kind of complement to the ability of our customers to be able to deploy highly available architectures. And I touched upon some of the machine learning capabilities in terms of, the fact that all of these are available, whether that is clickstream data, whether that is data warehousing, or the newer deep learning methods, right? We have a suite of services around machine learning that give you access to, image recognition, analyzing videos, deploying machine learning models on edge devices. So all of them go towards supplementing the core IT solutions that our customers use into the future. We have a strong ecosystem of partners. This is especially relevant because of the topic today. So for example, our partnership here with DiscoveryGarden, you can already see that some of these features that we talk about, they require some nuanced configuration sometimes, and having access to a partner that understands and knows how to make use of those features can go a long way into supporting customers. So from that perspective, one of the things that I always like to stress upon is, if you have application needs, make sure that you talk to your partner. You're talking about, you're bringing forth your requirements, and typically, those can be met with the available features in AWS. But even if there is a gap, right? Let's say there is some version or some feature that you might benefit from and it does not exist on the cloud today, typically we have the ability then to work directly with your partner, and then we are always listening. We want that feedback. We want to know what some of those gaps are, and in fact, that's how we kind of drive our roadmap. We try to launch all these service features based on the feedback directly from our customers. So know that, if you see something that you might not like, you have gaps there, your voice can be heard. You can make that available to your partner or to AWS directly. So with that, we start with the global reach section. And what on this slide, the most important aspect is there are about 24 regions today. And so before I go further, it is important to understand the concept of regions and what those are. So a region is kind of a self-contained geography where your solutions and your applications can be deployed. We have one in Canada. We have multiple regions in US and all over the world. The benefit is that if you have strong data residency needs, if you, for whatever reason, your applications need to stay within a specific geography, then you can, as a customer, you get to decide which regions your applications get deployed to. And then AWS by default does not make or move any copies of your data to anywhere else. If the customer requirements are such that for data preservation or for some, and we'll touch upon, you typically don't need to do that for data preservation. But if you have very strong needs where you need to make copies into geographies that are kind of words away, that option still exists. So this slide kind of, the main point to understand is that the AWS infrastructure is available throughout the world, and it is self-contained within certain geographies. And then as a customer, you get to pick and choose which ones you want to work with. In terms of availability zones and what these regions are kind of made up of, right? So it is a good concept to understand. Each region is made up of typically 2 or more availability zones. And oftentimes you'll see we more than once we have, typically 3 availability zones to begin with. So in this case, for example, if we talk about the Canada Central region, it is made up of 3 availability zones. Now, an availability zone from a customer's perspective for all practical purposes is an equivalent of it's a logical data center. So in your typical on-prem solutions, for example, if you're making use of multiple locations through using different data centers, this is an equivalent of that. The typical difference is, though, from a data center, because there are nuances actually. Each availability zone is further made up of one or more data centers, and oftentimes it's more than one data center under the hood. The reason I say the availability zone itself is like a data center is because the customers, when they are deploying their applications, this is the level of control the customers have. The customers pick and choose which availability zones their applications are deployed to, how many of the availability zones they are going to make use of in their application deployment. And that in terms gives them options in terms of how much redundancy they want to introduce into their application architecture. So there's always you're always looking typically at a trade-off between cost and the reliability of your applications, right? So if you're deploying it into multiple availability zones, you do introduce high resilience, right? But that comes at the cost of running some of the infrastructure redundantly. And there are techniques to optimizing that as well. So even in terms of, even if you're running things that, let's say, your application scales horizontally and you're running some servers in both the availability zones, there are techniques then that let you run a small footprint of these servers and then scale them as your kind of traffic increases, as your needs increase for serving that traffic to your end customers. Now, in terms of a unique characteristic to understand for availability zones is these are on different fault planes. What I mean by that is the availability zones are typically fed with redundant power supplies. They're fed with redundant ISP providers. They are on different floodplains. They're designed so that an interruption in one of the locations does not potentially affect the others. So from that perspective, it gives you a unique capability. If you are deploying your applications across these availability zones, then any interruption to one of those locations is kind of, you're foolproofing your application from that perspective. Now, when you do that, one of the key concepts is that the latency aspect between these availability zones, even though they are on different fault planes, they are still close enough where the latency between any two availability zones is always a single digit millisecond latency. What that gives is our customers, it gives the ability to create synchronous replication across these availability zones. So if you're deploying applications that simply cannot take any data loss, you can have your data replicated across these availability zones in a synchronous fashion where you're not introducing additional latency to your end user response time. At the same time, your data is always maintained across these different locations. And even in case of an interruption, you can always fall back to the other location. This is especially reflected in the relational database service that I talked about, where if you deploy your database that is kind of redundant across these availability zones, that's typically called a multi-AZ deployment, then that is behind a DNS endpoint. So the primary database, if it ever has an interruption, the secondary is automatically, for example, upgraded to primary. So from an application design perspective, if you are making use of a multi-AZ deployment, your application does not see any failure because it's always talking to a DNS endpoint, and that DNS endpoint is always talking behind the scenes to a healthy database instance. Again, I touched upon some of the kind of the facts about redundant power supplies, right? Redundant ISP providers. One of the other key concepts to understand is within each region, there is a concept of transit centers. What that means is, in terms of network connectivity, we go out of the way to create redundant network connectivity amongst all of the nodes within an availability zone as well. So a region will always have more than one transit center, and each transit center then is redundantly connected to multiple data centers within the availability zones. What this means from a customer's perspective is even if there is a networking link failure into one of these kind of locations, one of these direct endpoints, you are always assured that your applications will still continue to talk. Your availability zones are still going to be available to your application. So in fact, this is further kind of enhanced with, well, we have a later slide that shows you even amongst regions, there is highly available networks, 100 gigabit per second networks that are fully redundant. So we'll look at that later. But this is within a region, how much redundancy we introduce to make sure that our customers do not experience interruptions. In terms of, again, in terms of points of presence and CloudFront, these are basically your, if you think about content delivery networks, these are equivalent of that. So these are locations where, even though the regions are 24, but your application, when you deploy it, if your users are spread throughout, the application can be served from these edge locations. So these are our caching locations, if you will, which are much closer to wherever your users might be. And that introduces, it improves on your customer experience when your customers are accessing your web properties, for example. Another key point is in terms of data kind of sovereignty. One of the key things is there is something called Direct Connect. And we have more than 100 locations for Direct Connect across the world. And what these provide you is the ability to connect your on-prem data centers through a fully private connection into the AWS cloud. So irrespective of where you are located, chances are there is a closer Direct Connect location to you, which can give you a fully private connection into the cloud. So this goes to improve network availability. It goes to improve the security posture for your cloud deployments. And like I mentioned, even amongst all the different regions and all the different locations for Direct Connect, we have a highly redundant network, 100 gigabit per second network amongst each of these locations. Now, we quickly get into AWS security. So I will not spend a lot of time here, but what I wanted to mention is there is, our customers have various needs. And one of the key things that I touched upon earlier was we work with some of the world's top security customers, and their requirements in turn drive the footprint for various AWS services. So what that means for you as an end customer is that all of these services, they are built with the requirements from the most stringent security and conscious and privacy conscious organizations. And if you're looking to achieve certain type of compliance yourself, so the chances are that the requirements that have been driven by these organizations, they have been baked into the services, and they can help you achieve those compliance requirements on your end as well, much faster. Now, in terms of how you get to achieve those things, one of the key aspects is having visibility, and cloud brings enhanced visibility into all your workloads by default. So one of the key services to that effect is a service called CloudTrail. What this does is it gives you the ability to see who did what and when, right? So when you turn on CloudTrail within your AWS environment, it automatically captures who performs actions, when those actions were performed, what was the action that was performed, where was the action performed to? In other words, that US East 1 is, in this example, that's a region. So in that region, a change was made, and the source IP address from where that was done. So what this means in terms of your security posture is, without you having to create additional configurations, additional application overheads to be logging in a central place, to be capturing all these details, these are captured on behalf of the customers by just turning on this service. Similarly, another service that works more on the kind of the application log level and the metrics level. So if you're monitoring, for example, your CPU levels, your RAM levels, right? This is the service that gives you access to all of that underlying data. So again, you can do all of this on yourself, or if you're making use of AWS Cloud, for example, this is all available by just turning on this one service. So your logs are all kind of going into one place. You don't have to worry about shipping them. You don't have to worry about visualizing them. There are a lot of features built in. You can define alarms on top of these logs to be able to then create kind of trigger conditions, right, based on which you can actually make them actionable. So one of the example could be if your CPU drops to, CPU utilization goes to 85%, let's say, and you're experiencing more and more traffic, you can automatically trigger spinning up additional machines, right, or additional EC2 instances, for example. Now, I touched upon this. AWS provides access to a lot of compliance and certifications, right? So there are a lot of reports. In fact, the link there provides you full access to all of the different certifications different services might have. And what that means is for you as an end customer is you can, when you're making use of these services, and if you have to achieve compliance on your own end, you can count on certain parts of that compliance to be coming from AWS directly. So any of the portions where AWS has to provide you capabilities, and this goes into the shared responsibility model. Typically, when you're deploying applications from security perspective, there is some things that AWS brings to the table, and there are others that the customer is responsible for. So in that sense, if you're trying to achieve a certain compliance, all of the physical hardware and security and SOC reports, for example, in connection to that, are made available by AWS. And then AWS additionally makes available a multitude of tools that further give you access to be able to kind of run on your part of the security model efficiently, right, and still achieve compliance. So the idea here is that just because something is compliant from AWS perspective does not automatically translate to the customer's compliance. Customer still has typically additional steps. And this will make sense if you think about a typical example. Let's say you're running a virtual machine in the cloud. We make sure we secure the machine from physical access, from networking standpoint, from hypervisor level. But if you look at who has access to this machine, you as the end customer have full control of that. So which operating system you're using, which patch level you're using, which users have access, whether you're encrypting data or not, are all decisions that you as an end customer make. And obviously that means there are certain aspects of it that you need to design when you're looking at your applications. And this is where having a partner like Discovery Garden can be very handy, because this translates directly into achieving that compliance by making use of their experience. So again, this goes into, when you're talking about security, it is typically achieved with multiple layers, and whether that is network, whether that is physical security, whether that is encryption, there are features available at each layer within AWS. So in terms of identity and access management, we typically make use of the traditional role-based security model, where users get to authenticate. They're then authorized, basically, that controls which permissions they might have. And everything is also captured, for example, through services like CloudTrail, where we make audit capabilities available to the customers. Again, in terms of various role-based security models, there is your root account. You can create multiple users under the root account. And then there is also a concept of temporary security credentials, where there are short-lived credentials. They live only from 15 minutes to, let's say, a few hours. And those are configurable. So you can make use of a combination of any of these type of credentials to secure your workloads. In terms of encryption, again, we provide you services that make options available for both in transit as well as at rest encryption. So whether you're using a database, or you're launching a new server, or you're making use of a data warehouse, we provide you with mechanisms to both provide encryption at rest and in transit. The encryption at rest, which is basically the data is encrypted using keys. And there is a service called Key Management Service that provides you access to, so you can basically create your own customer keys, and making use of your customer keys, you can gain full access to all of the encryption under all the services. So from that standpoint, you control your encryption keys, and hence you are in full control of your data. That brings us to the storage section. One of the key things here to understand is the durability aspect, and this goes and directly ties into the data preservation aspect of the presentation, right? So in order, the services that are going to be of interest today that we talk about, S3, for example, which is a simple storage service, provides you with 11 nines of durability. And this slide goes to show that in order to achieve 11 nines of durability, you need to have at least 3 different physical sites, and the data needs to be replicated across those sites. Remember I said each region is made up of typically of at least 3 availability zones? This is exactly why. Because in order to deliver even the most basic services like storage, we need to provide our customers with those many options. So again, not all parts of this are relevant for the today's discussion, but the key part there is whatever kind of storage services you might need, there is a corresponding service available from AWS. The most important one for today's discussion is the Amazon S3, which will kind of, when we talk about that, it provides you with 11 nines of durability. And that translates into, like, I think if I'm not mistaken, 1 in a trillion kind of chances of losing something. And it scales limitlessly, which means you don't have to guess any capacity. You can keep adding your data. There are no limitations. We have customers that have petabytes or exabytes of data stored in S3, and this service you can just continue to use. In terms of pricing, also I have put specific pricing for Canadian region. It is only, for example, 2.5 cents a month for every gig of data stored. And one of the last slide that I want to look at is that is the most expensive service tier that you see within S3. So as your requirements are determined appropriately, you can actually make use of this tiered approach to S3, where you can actually start making use of, for example, if you have archiving needs, strictly from data preservation, but you don't need to access this data very frequently, you can start going towards the right side of this slide and start making use of services like Glacier. So typically customers, when they need to hold on to data for multiple years, but they don't need to use it every day, they start making use of these services. And if you look at the pricing aspects, you'll find that from 2.5 cents, you're now going all the way. If you look at the Glacier Deep Archive, you're going to, 0.18 cents, right, per gig of data stored per month. So you can find the right balance with the you can balance it with your needs to how frequently you need to access data. And just because it's cheaper does not mean it's any less reliable. It's still replicated across 3 availability zones, still provides you with 11 nines of durability. So from that aspect, I wanted to touch upon the fact that things are distributed. Things are directly, some of these storage services impact your data preservation styles. And some of this is then further explained in the next section that Luke will talk about. So with that, we get to specific Discovery Garden architecture. And Luke, if I can request you to join and take over, I can work the slides from here.
Okay, great. Hello. Thank you, Tulsi. Today, I'm going to give a high-level overview of DGI's Island or AWS solution, which is going to be intended for more large-scale deployments. It's important to note that this solution is still under active development, and some components could be subject to change, in particular after Amazon reInvent, which has announced a lot of exciting features, such as multiple destinations for bucket replication, which is great. That's extremely valuable to folks like us. Given the context of the webinar and time constraints, I'm going to try to focus mostly on AWS specific services during this. So one fantastic improvement with Island or 8 is the flexibility of Fly system. which allows us to use Amazon S3 for the repository backing. In the old solution, we were a lot more limited. We had to use NFS network type storage, like NFS, or block storage. But now we can actually use blob storage, which is S3, which offers a lot of features that was outlined that Tulsi outlined. So some of the things that we're going to be making use of is we're using versioning to record any changes. We never delete any data. All versions of every object are kept. Live data costs are effectively managed using intelligent tiering, while any older versions will always end up going to Glacier Deep Archive. It replicates data to a completely separate account that is only accessible by management at discoverygarden. That way, it's an additional layer of protection that if an account got compromised, for an example, it would exist in a completely separate account. S3 API calls are monitored through GuardDuty. Additional levels of access monitoring can be enabled depending on the cost, such as S3 access logs. IAM keys are not going to be used for any of this. We only use service-based roles, which enhances the security. AWS config will be used to help monitor and provide reporting on resources to ensure such thing as bucket encryption, TSL enforcement, and importantly, ensuring that buckets are not going to be publicly accessible. Additional features will be available at higher storage tiers, such as cross-region replication. So you could basically have your data going to the same region, but you have an option if you want to send it up to the other side of the world. Additional features will be making available at higher storage tiers, such as object locking, which is basically worm protection for a defined period of time. So worm protection stands for write once, read many. So this protection can protect your data to ensure that it cannot be deleted, even by your root account. So like with this enabled, I myself couldn't even delete your data for the defined period of time for the contract. So as mentioned by Tulsi, the data in S3 is replicated across at least 3 different availability zones per region. When using the bucket replication, it's actually an additional copy of data, which is also replicated across 3 different availability zones. So effectively, like if you look at that diagram with their stock, like with their base storage offering, it's actually that's 6 copies effectively of your data that's being replicated with the option of having it actually exist in another availability zone. Just to move on to the next slide, I'll actually talk about a better stack. And forgive me if I'm talking too fast, just we don't have a whole lot of time, so I'm trying to squeeze as much information in as possible. And I mean, if anybody has any questions, you know, my email is luke@discoverygarden.ca if there's not enough time in the Q&A to get to your question. So the stack, this is our what the actual stack looks like. The stack will shrink and grow based on load. So it can survive the loss of an availability zone or a crashed server, and it won't leave unnecessary resources running beyond what is needed for the minimum level of service. So what that means is if you have a high load, depending on the tasks that are being carried out or what's happening, it will basically spin up additional resources and then spin them back down once the load is passed. So we're utilizing a number of AWS technologies to make this possible. All resource management in AWS will be carried out as infrastructure as code using AWS CloudFormation. You can see in this image, each service icon represents an autoscaling group. That's what those little arrows mean. These autoscaling groups are tailored to allow the underlying service to grow and shrink on need. The autoscaling group will replace lost instances in the event of a failed availability zone. The elastic load balancer will bounce the load across multiple instances for a particular group, so that one instance doesn't end up taking the entire load. It actually will divide it up across the instances. S3 VPC endpoints, as you can see in the top right-hand corner there, are used to ensure that the S3 traffic stays within the AWS infrastructure, thus is more secure and performant. Amazon MQ is used as a drop-in replacement for active MQ. We'll be using Amazon MQ instead of SQS because Island Door actually is a stomp requirement. So that it's slightly more expensive, but that could change down the road if things end up changing within the application. Aurora Serverless is used instead of a traditional database server. Aurora Serverless can scale capacity on demand and it requires a lot less management than your traditional database server. You'll notice EFS there. So this is actually just used to store the Drupal sites directory and private files, basically to keep things consistent across multiple Drupal instances. We'll be utilizing CloudWatch, which is used for many purposes, such as central logging and triggering various tasks based on different events, such as autoscaling. Service monitoring at this point in time will be carried out using services such as CloudWatch and external open source tools such as Nagios. AWS config and AWS stack drift detection will be used to monitor out-of-band configuration changes for key items such as encryption and resource exposure. We use Amazon SSM, actually both for i7 offering and the Island Door 8. We use this to track instance inventory, things like patch compliance, etc. We'll be using Amazon Cloud Map. This is actually going to be used to track resources for things such as in Solar Cloud. You have to keep track of the Solar Cloud nodes and the Zookeeper nodes. And Cloud Map is going to help us to maintain a set of that so that if one of the Solar Cloud nodes needs to know what healthy Zookeeper nodes are, it'll be using Cloud Map to get that information. We can enable VPC flow logs for forensics, or if you need it for compliance purposes. We use Amazon GuardDuty and Oliver accounts, and this will also be used to monitor any API calls that are involved with the stack. Any backups that are needed, such as with the EFS or any snapshots, are all being carried out by AWS Backup. It's not detailed in this diagram, but the intent is that we'll have a web application firewall and AWS CloudFront fronting this application. That is still under active development. Just to talk a bit more about what these different tiers mean. So you can see in this diagram, it shows an Amazon VPC, which is basically a virtual private cloud. You'll have 3 different sets of subnets. Each set is across multiple availability zones. Depending on which set it is, it may or may not be able to communicate through the internet. This is by design. This is intended to improve overall security of the stack. So the public subnet will actually have a public IP address that you could access directly if the ports are open. And these can communicate with the internet. Instances set in here can be accessed directly from the internet if the ports are open. The Bastion host, which is used for management level access to get to, like, so for example, if I have to SSH in a server to look at something, I'll have to go through the Bastion host, which would be locked down to trusted sources such as discoverygarden's office. So the private web tier is basically these instances don't get a public IP address and cannot be directly accessed from the internet. Instances can use the internet through something called a NAT gateway, as you can see in that diagram, to access any external services. Ideally, I like to put everything into the private backend subnet. However, there's some things that are having trouble with that, such as IIIF viewing. So there's going to be some things that's going to have to be in the private web and other things in the backend. Ideally, my approach will try to push everything into the private backend wherever possible. So our updates will mostly be controlled through like a golden image, or the AMI, which is actually assigned in the launch configuration for each autoscaling group. So our deployments would actually be controlled through that way. So I mentioned the private backend. Anything in there do not get a public IP address and cannot actually be directly accessed from the internet in any way. So I would consider it the most secure subnet. I'm not sure how I'm doing for time here. I might actually be getting over. I know that was a lot of information to throw at everybody all at once. I mean, I'll look forward to future webinars where we can maybe get a bit more in depth into the actual Islandora services that are being involved here, because I'm sure everybody has a lot of questions on that. I guess with that being said, if we want, Tulsi, we can move on to the Q&A section, because I think I'm probably out of time.
Thanks, Luke. Thanks, Tulsi. Wow, lots of content packed in there. Appreciate you both sharing so much good detail. I will ask if anyone has any questions to just use the Q&A or the chat function to submit any questions that you may have. And if not, if there are no questions, usually we have a couple that come through. I think Luke gave his email address, so we'll be sending out the recording afterwards, and we'll be sure to include that as well, so you have it. I don't see any questions. Don't be shy.
I don't know if that's a bad sign or not.
Just a comment so far, no questions. If there are no questions, I'll just move to closing it up. So want to really thank Tulsi for joining us. Really appreciate your time and you stepping us through, Tulsi, some of the foundational elements of AWS, but then also sharing together with Luke some of the applications that, we do have a question that came through. Is there a website to share the stakeholders that describes how S3 Deep Glacier 3AZ redundancy addresses risk? Question from Robert. Tulsi.
Yeah, I can take that. Yes, absolutely. There is actually a lot of information. So even just the default page for the service. So each service kind of has its own web page. They typically has links to resources where there are like good amount of white papers and further sort of question and answer format responses also. So I'm not sure if you're looking for something specific. If you're looking for something specific, please do connect with Luke and myself. I can point you to like a specific document, but in general, there's lots of information that is available. Yes. And I can point you to a link post this. I can include a link with the presentation deck later.
Great. Any other questions? Thanks, Robert, for your question. Okay, if not, I think I agree. I don't know how to take it as a good sign or not, but we'll take it as a good sign and end it on an optimistic note. So thank you so much, everyone, for joining today. As I mentioned, we'll have some follow-up information available. We do post the recording of our webinars to our YouTube channel, but I'll send that link out probably tomorrow. So thanks for your time and hope you all have a good rest of the day. Thank you, Luke and Tulsi, once again. Take care.
Thanks, everybody.